Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video I'm going to go over the asynchronous delay and specifically what happens when the millisecond counter hits that top value and rolls back over to 0. I've included some things in previous videos on how I choose to handle it, and it turns out that what I have is completely wrong. So I'm going to go over what I did and then what I've changed going forward. I've taken my previous code and I've just snipped out the async portion of it so that I can kind of go over that and just focus on that. And in the past what I've done is I've defined a variable called async delay. I've set it started at equal to 0, and that just counts up and keeps track of the async delay compared to the milliseconds. If you notice, I have an unsigned long for it, which is the same size as the millisecond delay. And this is the value, 4,294,967,295. That's the maximum value it can read before it rolls back over to 0. And then I have another variable I use as my delay length. I just have that set to an integer because that stays constant. I could actually have it as a constant in there, but I've just always used it as an integer. And then I have a note down here to remind me that the milliseconds is an unsigned long. Now for testing, I have the serial begin here, so I can use the serial port just to output some code for just to try and make things a little more clear through the video. And then I always have the pin turn on and off, but since I'm not going to show the Arduino in this one, and I'm going to use a nano for this, but since I'm not going to show that, I went ahead and left the serial on so I can bring up the serial monitor. And this is a pretty standard copy of what I normally include in it. And my thinking was my milliseconds is going to count up right here to that 4 trillion or 4 billion number. And I was wondering, well, if my async were to count beyond that and lose track, for some reason I didn't think the async would also roll over. I was thinking it would just keep on counting up and above that. So I always thought I needed to check for that. But to begin with, this is the same. So I take my milliseconds and I compare it to the async delay plus the delay length. So that meant after 3,000 milliseconds or 3 seconds, I would execute this down here. And then as long as everything was fine, it would just add another 3,000 milliseconds or 3 seconds, and then it would just loop it again. But what I was testing for here is I wanted to know if my async delay, which is continuing to count up, was ever in that spot where it was gonna roll over, where it was going to be so close to this 4 billion number that the next time through it would roll over. And I thought for some reason that I had to take that into consideration, but it turns out since it's an unsigned long, I didn't have to. So this whole time I've been worried about this, I really didn't have to worry about this portion of it. And so then I wrote this code though that supposedly would take care of that rollover. But it doesn't. If you look, it takes that top number and subtracts the async delay, and it does it twice. It does it over here and it does it over here. So I take my delay length, which is 3,000, and I subtract from it a certain number, and then I add that same number to it, so it stays 3,000, and I assign it to this asynchronous delay. So essentially what I'm doing is as I get very close to rolling over, instead of allowing it to roll over, I move it to 3,000. So I set it back to 3,000, which would work just fine, but you would have a little bit of an error there when it hit that 4 billion number. And like I said, I wouldn't have to do any of it. Just ignoring 4 of these lines and putting the async delay plus equal delay length takes care of pretty much everything at this point. It would be more accurate, and it would still work just like it does right now. So going forward, I'm going to make a change, and this video I'm going to go over how I'm going to handle it going forward. But instead of worrying about this 4 trillion number or 4 billion number, I'm going to switch it over to a byte. But instead of using the millisecond command, we're going to use a variable, and we're going to call it millisecond test, and then we're just going to increment that manually rather than it incrementing through the automated millisecond function. So like I said, we're just going to change a couple of things in here. My delay is going to be a byte now, so it's only going to go to 255. My delay length is going to be the same, only I'm going to set it to 10. And we can pretend it's milliseconds, but like I said, I'm going to count it through a delay, so it's not going to be exactly milliseconds. And then this byte millisecond test is going to simulate our millisecond function. Then I have my serial begin just like before. I'm making the pin toggle. I'm going to make the pin toggle just like before, even though I'm not going to show it. And then in the loop, I'm going to delay 20 milliseconds. Then I'm going to increment my millisecond test, just like the millisecond function would increment itself. Then I'm going to print the current milliseconds, and I'm going to compare it to the byte delay, to where we're currently sitting. So the first time through, the millisecond will be 1, the byte delay will be 0, and so when we do this function down here, the millisecond test is going to be greater than the byte delay, and it's going to execute this. Then the byte delay is going to add the byte delay length, which is 10. Then we're going to print it out that we've done that, so we've changed the byte delay. And then it's going to take a count of 10 again, or this is going to have to loop 10 times before this will execute again. But if you notice, I got rid of all those extra lines in the delay itself. Now just to show you what I was worried about initially, up here in this byte delay, I thought that the byte delay would count beyond the milliseconds. So I'm going to change this to an int. And so this will simulate the problem that I thought I had to correct for, and then we'll change it back. Okay, you can see it's counting just like we thought. 1, and then it changes it to a 10, and then at 11 it changes it to a 20. So every 10 counts, or 10 milliseconds, depending on how you want to look at it, it's going to make a change. But the problem is going to occur when it maxed out, and in this case we have our millisecond test set to a byte, so it's going to happen at 255. So at 250, we count up to 251, and then it set it to 260. The millisecond test is never going to hit 260 because it's going to roll over at 255. So it's never going to be greater than 260, so at this point we're just stuck. And I'll scroll down, and you can see it just sits there at 260. And so that's the problem I thought I was correcting with the previous code. So what we're going to do is we're going to take advantage of the rollover included, and we're going to do that simply by changing this up here back to byte. And you can see initially it looks identical. It's when we get to that 255 that you notice the change. And this is where you still will have an error, and it wouldn't have really mattered which way I did it, because I was resetting that back to a small value when I hit this last count. So I hit 250, and then it starts to count up our millisecond. Every time we go through this loop, it's going to increment to 242, 243, 244, and once it hits 251, then it's going to add 10 to this 250, which you would think is 260, but since it rolls over, it turns it into 4. Because it hits 255, then it hits 0, then it hits 1, 2, 3, and 4. Since the millisecond continues to count up to 255, as you can see, it's going to go 251, 252, 253, 254, and 255 before it rolls over to 0. It's going to continue to go through this loop right here, and it's going to add 10. It's going to do this byte delay, and we're going to keep adding 10 to it every time it's greater than. And you can see it's always going to be greater, even though we add 10 to it every time, it's going to be greater. But what we really want it to do is we don't want it to add anything for these first 4 sections here, because we want to go 10 counts without adding anything to it. Now it's doubly bad because not only do we add to it, but we add to it each time, so it's up to 44 by down here. So now we're not going to add anything to it until it hits 44. Well, actually 45. So at 45, then it sets it to 54 because it adds 10. And then you can see we get back to our 10 and our 10 and our 10, and then it works. So we have to come up with a way that detects when our async delay variable has rolled over to a low value, but our millisecond count still has to count up to that 4 billion, or in this case 255. And we're going to do that by introducing another variable. At least that's the way I'm planning on doing it at this point. It may change over time, but right now I'm going to do a variable. And my plan is once it's changed, like once this count has gone to 4, I don't want it to change again until it fails the test. Like in this case, it's still passing. 252 is greater than 4. 253 is greater than 14. 254 is greater than 24. 255 is greater than 34. But here, 0 is not greater than 44. So once it's passed this test once and ran through this asynchronous delay, I don't want there to be an option of running this async delay until it's failed. Hopefully once I show you this, it will make more sense. And I'm going to add this variable called rollover. And that'll just let me know when it's okay to execute this code within the delay itself. I'm going to change this string so it's going to print out the rollover state so we'll know what's happening. Hopefully that'll make it a little more clear as we go over the code. So now not only does millisecond test or milli-s test have to be greater than byte delay, but the rollover state also has to be equal to 1. And if it's equal to 1, then we'll go ahead and run this. But what we're going to do is as we run this, we're going to set rollover equal to 0. So that way when it runs through this again, if millitest is greater than byte delay test, but the rollover hasn't been reset back to 1 because we set it to 0, it's still not going to execute this. So now the only time we want this to go back to 1 is if it fails this test right here. So we'll put an else down here. And now we'll run it. And now it's going to pretty much look the same except for we've added this rollover variable. So the first time after it makes its change, we set the rollover to 0, but then 3 is not greater than 10. So over here, since it fails this test, it's going to set the rollover back to 1. And so this time, when 11 is greater than 10, or up here again, and it passes this, it's going to say, yep, rollover is equal to 1, and it's going to execute this. But then it's going to set rollover equal to 0 again. And then the next time through, it will fail, and it'll set rollover equal to 1. But now we'll go down to 255, and we'll see how it handles it down there. So now when it's at 250, we see it's going to count up. But at 251, it's going to go to 260. Or in our case, it's going to go to 4 because it's going to roll over. But then rollover was set to 0. Well, 252 is greater than 4. So it's going to pass this portion. So it's not going to run this else down here. And it's not going to run this because rollover isn't equal to 1. And it's going to do that until it fails this test. So when 0 is greater than 4, which isn't true, then we're going to run this. It's rollover equal to 1, and you can see we set rollover equal to 1. So the next time that 5 is greater than 4, it's going to increment this. So it should handle this better during this rollover. But there is one spot where now this will not work, and that's if we set our delay length equal to 1. If I set my delay length equal to 1, we're going to have a problem. But I've chosen to just deal with this problem because how often are you going to set your delay to 1 millisecond? And if you did, maybe you could go down to microseconds or something like that. And what you see is 1 is greater than 0, and rollover we set it at 1. So the first time through, it's going to increment our byte delay to 1, went from 0 to 1, but you can see it has to fail this first in order for rollover to be set to 1, and you can see it never does. Now that's not exactly true because once we roll over, then it will. So we'll go down to that 255 spot where it rolls over. And you can see at 255, since the millisecond test gets reset to 0, 1, and 2, it does get, the rollover gets reset to 1 because it failed this test, and it'll go to 2. So every 255 counts or milliseconds, however you want to think of it, it will reset. and next time it'll be at 3 and 4 and 5, but that isn't what we're looking for. But the odds of me needing or ever setting this to 1, like I said, is very rare, so I'm just going to let that go for now. But there is another chance of error. Actually, there's 2 more, but we'll cover one at a time. In order to display the error, we have to reset this delay length to something else. I'm going to set it to 3. And we'll upload it. And you can see it counts 3. 3 is a pretty easy one to see. And it works good. And our first rollover is 0, and then 1s, and then 0, 1, 1, 0, 1, 1. The error happens when our async delay, or our byte delay, is equal to 255. So at 252, when we hit 253, it turns this to 255. Well, our async delay, or a millisecond test, the variable that we're incrementing every time through, is never going to be greater than 255. So once we hit 255, or if we happen to hit 255, you can see that we're stuck, and it just stays at 1 forever. This is a pretty simple fix to this portion. All we have to do is add an equal sign. And we'll add it to the string too, just to keep it clear. But now that we have this fixed, we're going to run this again, and we still have one more issue that can come up. But first I want to show you that it does work, because here we set it equal to 255, so 255, 255, and if it's greater than or equal to, it works. Then it goes to 2, and then we continue on down the road. The only thing is, it does happen 1 count earlier than it did before, because before it was looking for greater than, now it's looking for greater than or equal to. You have to leave the greater than. You don't want just the equal to, because if it were to miss for some reason, like in milliseconds, they can happen a lot faster. So if your code doesn't get to it immediately, and let's say it jumped from 1 to 3, you'd still want to execute the delay. So you need to keep the greater than, but just add that equal to, and that helps out this 255, greater than or equal to 255. But this does present one more problem, and we're going to go over that next, and that should be the last portion. So the last error is what happens if the byte delay equals 0. Because if it's equal to 0, then the next commands are, this will always be true. Because now we're comparing this millisecond test greater than or equal to byte delay. Well, it's always going to be greater than or equal to if byte delay is 0. So then we get stuck going that way too. What we have so far is if this is greater than or equal to byte delay, it won't do this. But if it's less than byte delay, it will do this. Well, our case is it could be equal to byte delay. So we're going to remove it from the else, so it's not part of this if command, and we're going to add it to its own. So we delete that. And I'm going to put it above this serial print line so we can see the value of rollover after it's changed. And one of the big changes you'll see now is that you won't see the 0 so much anymore. We should still see it on the 255 rollover, but since we're comparing and making the change before the print line, you won't see the 0. But now we need to go and look and make sure at 255 it works, and when byte delay is equal to 0, it works. And here it is at 255, and it works fine. Now we'll go find the 0. And you can see here when it changes to 0, here's where it's kind of good, you do get to see the 0 on the rollover. Because when 255 is greater than or equal to 0, it's not going to change. When 254 is greater than or equal to 0, it's also not going to change. But once 0 is greater than or equal to 0, which it passes that, then it changes. Now if you want to stick around, I'm going to change the delay length to 10, and then you'll see more zeros that way. You can see up here when it changes to 250, and then when it hits 250, it'll change to 260, but it doesn't really, it changes to 4. But you can see the zeros. So we still have the protection down here, But then when it hits 0, we also use this statement up here to correct that. And so at this point, this is the way I'm going to protect against rollover going forward. It does incorporate an extra variable, and there's probably other ways to do this. I spent the week looking up how other people did it, and there's lots of choices on how to check for this. Some people even recommend adding a Watchdog Timer, which you'd put a little check within this async delay, knowing that it has to run every 10 milliseconds or 15 milliseconds or whatever, however often you think it needs to run. You make a delay that's a little bit larger than that. It's called a watchdog delay. It just kind of keeps an eye on things. And if that delay happens to extend too long, if you're not resetting a variable or doing something every, let's say, 30 milliseconds, and you want this to run every 10 milliseconds and it didn't reset that value, then it knows, hey, something's going on with the Arduino, and just restart the whole thing. And so there's a way to check for that. I might do a video on that. If people put enough comments in, I'll do a video of that, or go over to the Cheap Controls website and put a comment over there, and I'll do a video on adding a Watchdog Timer to this. But like I said, going forward, this should be what you'll see in my videos, something similar to this. And just to review, what I would do in going forward is you'll see an unsigned long async delay, just like in my previous videos, and I'll have a delay length. But I'm going to add this rollover variable in there. I may call it an async rollover. I don't know what I'll label it as, but I'll have something in here to define when it's okay or when it's in the rollover state. And then I won't need this line or this line, because I'll be using the millisecond. And now I'll be looking to see if the millisecond function is less than or equal to the async delay, in which case we're in the state where it's not going to execute the delay. I'm going to set the rollover equal to 1. And then I'm going to be checking in the loop, just like I did before. I'm going to check to see if the milliseconds is greater than the async delay. I'm going to leave this alone and check if the rollover is equal to 1. And if it is, then I'm going to increment the async delay by the delay length. And this will remain the same, and I'll reset that rollover back to 0. So in some ways it simplified my code, but in other ways it didn't, because I'll have to have this function up here, this if milliseconds is less than or equal to the async delay. So I've added this, but I've eliminated some lines down here. While I was reading up on this, I read up there's lots of different ways to do this and lots of opinions on it too. So I'm sure some people aren't happy with the way I did this, and that's okay, because everyone can do it a little bit differently. And as I said, if anyone wants to go a little bit further and would like me to incorporate like a Watchdog Timer in there to verify if even the delay is broken, I'll do that. But for now, I think I'm just going to leave the video where it is. I think it's been long enough. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.